All right, hey everybody, we are getting down to the last couple of videos in this class. So this is truly one of my favorite sections to teach. I so wish that we could be in person so that I could show this to you, and maybe by the time some of you see this, we are in person. So anyway, let's simplify complex rational expressions. First of all, it might be helpful to know what a complex rational expression is. And it is an expression. Remember, there's a difference between expressions and equations. Expressions do not have an equal sign. Equations have an expression equals another expression, okay? You can solve equations. You can only simplify expressions, okay? So we're only dealing with expressions, so we will not be solving for x, okay? All we're doing is simplifying as far as we can. So a complex rational expression is an expression in which the numerator or denominator contains a rational expression. Don't you hate it when they use the definition or the word that you're trying to define in a definition? So anyways, what this means is we're going to have some sort of expression in the numerator or denominator, or possibly both, and it's going to look like a hot mess. I'll show you what I'm talking about. Look at that. Like I said, a hot mess. Okay, so you have a fraction divided by another fraction, and notice this is an expression, this is an expression, this is an expression, this is an expression, okay? And so what we want to do is we want to make this look a little bit nicer, all right? So don't forget that a fraction bar does mean divide, all right? So we've got 4 divided by y minus 3 divided by 8 over y squared minus 9, okay? So don't forget that whenever you are dividing fractions, you keep the first one, you change your sign to multiplication, and you flip-flop your second one, okay? I think it's also a good idea to go ahead and factor. So let's do that. All right? So when we flip, we're going to write the factored form in the numerator of the second fraction. Okay, so keep the first one, change your sign to multiplication, flip-flop your second one. This is the same thing as multiplying by the reciprocal, okay? Remember, reciprocal just means flip your fraction. That's all it means. All right, so now we're going to mark out factors that are the same. And remember, you can mark things out vertically or diagonally, but never left and right, okay? So vertically, there's nothing we can do, but diagonally, sure, there is. That and that go away, okay? I can simplify the 4 and the 8. 4 goes into 4 one time, 4 goes into 8 two times. And now we just multiply straight across, okay? So this turns into y plus 3 over, everything got marked out but the 2, and that's it. We are done. It actually does look nicer, doesn't it? All right, so take a look at this. Now, we need to simplify the numerator. Okay, so I'm going to write that 1/3 plus 1/6. That's the same thing as 2/6 plus 1/6. Now we have a common denominator, right? 2/6 plus 1/6 is 3/6, which is the same thing as 1/2, okay? So this is our numerator, all right? Our denominator is 1/2 minus 1/3. So I'm going to get a common denominator. 3 over 6 minus 2 over 6, okay, equals 1 over 6. Now, our numerator is 1/2. Our denominator is 1/6. So it actually looks like this, which is the same thing as 1/2 divided by 1/6. Okay? Keep the first one, change your sign to multiplication, flip your second one. And now we can reduce and multiply straight across. Okay? And the other thing I want to point out, yes, 3/1 is the same thing as just 3. I always want you to write your answer in the most simplified form. So rather than telling me 3/1, tell me 3. All right, it's no longer just numbers in there. We've got 1/x plus 1/y divided by x/y minus y/x. Okay, so the first thing we need to do is we need to simplify our numerator. All right, so our numerator is 1/x plus 1/y. So what is our common denominator between x and y? Well, it's xy. Okay, so what do we have to multiply this guy by to get xy in the denominator? We have to multiply by y/y. Okay, for this guy, we need an x in the denominator, so we need to multiply by x/x. Okay, so we end up with y plus x. Okay, now we have a common denominator, so we can go ahead and add the numerators. Okay, so that's what our numerator is now. It doesn't really look much better, but it is simplified. All right, now let's look at our denominator. Okay, again, we need a common denominator, and that is xy. Okay, so what do we have to multiply this guy by to get it to be xy? We need to multiply by x/x. And what do we have to multiply this guy by to get it to be xy? We need to multiply by y/y. So we end up with x squared there, and we end up with y squared there. So this turns into x squared minus y squared over xy. Now, let's factor. Let's factor this guy right here. Okay, so I am going to write it down here. So I've got x minus y and x plus y. Remember, because it is a difference of squares here. So now, this is our numerator divided by our denominator. So I'm going to move this down. So I've got y plus x over xy divided by, oh, hang on, sorry, fix it, there we go, x minus y, x plus y over xy, okay? Keep the first one, change your sign to multiplication, flip-flop your second one. Okay, now, here's the thing. This and this are the same thing. Can we write this as x plus y? Totally, yes, that's okay to do. Oops, I don't know how to, clearly. Okay, x plus y, okay? Now, I can mark out my like factors. There and there are gone, and there are gone. Now, remember, whenever you mark out everything in the numerators, you can't just leave nothing in the numerator. So really what you have is you have 1 in the numerator, and the only thing left in the denominator is x minus y. And there we go. We are done with this problem. All right, so this is just a page telling you what we've already been doing. So to simplify a complex rational expression, you simplify the numerator and the denominator, which is what we've been doing. Then we rewrite the complex rational expression as a division problem, and then you divide the expressions, which you divide by keep the first one, change your sign to multiplication, flip your second one. All right, so let's take a look at this one. This one looks like a mess too. Okay, so I'm writing the numerator down, and I'm just going to simplify it with an n, okay? I'm just talking about the numerator. I better not, because we've got the variable is n in this one. Okay, so the numerator is n over 1. Remember, all I did was I put this as a fraction over 1, okay? Minus 4n over n plus 5. Now, what is our common denominator? Our common denominator is n plus 5. Okay, I don't need to change this one, so I'm just rewriting it over here, okay? But this one needs an n plus 5 over n plus 5, okay? So I've got to distribute the n, and I end up with n squared plus 5n, okay? Now, I'm going to do a change here, all right? And so then I end up with, whenever I combine my like terms in the numerator, I end up with n squared plus n, okay? Over n plus 5. Remember, your denominator doesn't change. Okay, so that's my numerator simplified. My denominator I'll do in purple. All right, so we've got 1 over n plus 5 plus 1 over n minus 5. Okay, so our common denominator is n plus 5 and n minus 5. All right, okay, so this one is missing the n minus 5, okay? So 1 times that is just n minus 5, all right? This one is missing n plus 5. And so we end up with n plus 5 in our numerator here, okay? So now whenever we combine our like terms, we are simply left with, because remember this minus 5 and this plus 5, they cancel each other. They're gone. So we're left with 1n plus 1n, which is 2n over n plus 5, n minus 5. Okay, so our denominator is now this. Our numerator is this. Our denominator is that. Okay, so now let's write this as a division problem. So we've got n squared plus n over n plus 5 divided by 2n over n plus 5 n minus 5. Okay, now let's mark out our like factors. Actually, let's factor this numerator first, okay? So I can factor out an n. They both have an n in common, so this would be n times n plus 1. All right? So let's see here. Oh, let's keep change flip. Sorry, I almost missed that part. Okay, so I'm left with n times n plus 1 over n plus 5. Change your sign to multiplication. Now we're flipping the second one. All right, now we can mark out some like factors. Okay, so n plus 5 and n plus 5 are gone. This n cancels that n, okay? So now what are we left with in the numerator? We're left with n plus 1 and n minus 5 over 2. And that's it. We are done. Nothing else we can do here. Okay, so now I kind of want to show you a trick, all right? Okay, so here's what you want to do for using the LCD. You might like this way better. This is a problem that we did previously in this video, okay? And so we already know that the answer is 3. So I just want to show you this little trick that is possible for you to use at all times. It does get a little more complicated whenever you add variables in, but let me just show you what's going on. Okay, look at the denominator for every one of these and ask yourself, what is the LCD between 3, 6, 2, and 3? And that LCD is 6, okay? So if I multiply the top, the top and the bottom by 6 over 6, remember I'm just multiplying by 1, right? Check this out. 6 times 1/3, that's the same thing as 6 divided by 3, which is 2. 6 times 1 over 6, that's the same thing as 6 over 6, which is 1, over 6 times 1/2 is the same thing as 6 divided by 2, which is 3. And then 6 times 1/3, which is the same thing as 6 divided by 3, which is 2. Okay, so now let's do the math. All right, so I feel like it was a much shorter way to get there, but it does get a little more complicated whenever you introduce variables. So let's take a look at that. All right, so now we have variables introduced, right? So let's take a look at all of these denominators. So we have an x, we have a y, we have a y, and we have an x. Okay, so that makes this pretty easy. Our common denominator is xy. Our LCD is xy or yx. It doesn't matter what order you say that in. So let's multiply the top and bottom by xy over xy. Okay, remember xy over xy is just 1. Multiplying by 1 does not change the value of this thing at all. Okay, so whenever I multiply xy times 1 over x, the x's cancel and I'm left with just plain old y in the numerator. Whenever I multiply xy times 1 over y, the y's cancel and I'm left with just plain old x. When I multiply xy times x over y, the y's cancel and I'm left with x squared. Okay, remember x times x is x squared. Whenever I multiply xy times y over x, the x's cancel and I've got y times y, which is y squared. Okay? Now I'm going to factor the denominator, which, by the way, doesn't matter if I write y plus x or x plus y. It really doesn't. The denominator factors to be x minus y and x plus y, okay? And if I rewrote this, swapping the place of these, I would have x plus y in the numerator, right? And I can get rid of that and that. So I am left with 1 over x minus y, which is actually what we got earlier. All right, so this is just telling you what we've been doing for the last couple of problems by using the LCD. So you find the LCD of all the fractions, all of them, in the numerator and the denominator, and you multiply the numerator and denominator by the LCD. Okay, and then you just simplify from there. I know that step 3, hey, yeah, you just simplify from here. It can be a little more complicated than that, as you know. All right, so let's do that same method with this problem, okay? So let's see here. The first thing I want to do is I want to factor this denominator, and it's a difference of squares, so it factors to be a conjugate pair, okay? So now, what is our common denominator? Our common denominator, because we have a z plus 6 here, we've got a z minus 6 here, and then we've got both of them here. So our common denominator is actually both of these, okay? So I'm going to multiply the numerator and the denominator by z minus 6 and z plus 6, okay? I'm going to write this just a little bit neater, though, okay? So, or at least I hope so. So, my numerator, I am multiplying z minus 6 and z plus 6 times 2 over z plus 6, okay? So that means that this and this cancel, and I'm left with 2 times z minus 6. So that's my numerator, okay? My denominator is, I'm going to multiply by this again, the common denominator, times 4 over, oh, by the way, let's put that in parentheses. Okay, so we're going to distribute this times that. So let's see here. This cancels the z minus 6 right here, but I don't want to mark it out because I've got to use it over here. So all I have left right there is 4 times z plus 6, okay? Now, whenever I distribute this times that, they all cancel, right? That, and that. So I'm left with minus 4, okay? So now we need to multiply this out so that we can combine our like terms. So we've got 4z plus 24 minus 4. So I'm left with 4z plus 20. So that's my denominator, okay? So my numerator is this. My denominator is this. So I've got 2z minus 6 divided by 4. Oh, wait. I'm factoring that. Is that okay? Okay, so 4 times z plus 5. I don't think it helps. Well, it does a little bit. Z plus 5. Okay, so now I can reduce that, and I'm left with z minus 6 over 2 times z plus 5. Yeah, there we go. All right, that's it for this problem. Oh, before I move on, there's a couple of things I want to say. First of all, I apologize that these are X's and not Z's. My eyes are not working right now, and I don't have my glasses on, so I apologize that I used a Z instead of an X. So anyways, first of all, that is my mistake, but again, the Z and the X can be interchanged here. The other thing I want to say is this answer is a perfectly good answer. Another good answer would be if you multiplied that out. So you could also have again, I'm using Z's again, sorry. So this one would work as well. Either one of these circled problems would, I believe, work in your online homework. Okay, let's take a look at this problem. Okay, so the first thing I want to do is I want to factor this denominator, okay? So I'm just writing my numerator. Okay, and so I've got 4 over, and if I factor that, boy, I sure do hope it factors to be those two things. And guess what? It does. Okay, and so what I want to do is I want to multiply top and bottom by the common denominator, the lowest common denominator, which happens to be m minus 3 and m minus 4. Okay, all right, so I am multiplying, hang on, so m minus 3, m minus 4 times 4 over m minus 3, m minus 4, okay? So what that does is this cancels this, and this cancels this, and I'm left with simply 4 in the numerator, okay? My denominator I have m minus 3, m minus 4 times 3 over m minus 3. Oops, that's terrible. Minus 2 over m minus 4, okay? Oh, I don't need that. I do need that there, though. Okay, all right. So when I multiply this whole thing times that, the m minus 3's cancel, and I am simply left with 3 times m minus 4, okay? This minus sign, I'm going to bring that down, minus, now whenever I multiply this times that, the m minus 4's cancel, and I'm left with 2, because that's the numerator, times m minus 3, okay? So now I'm going to go ahead and distribute a couple of times, and I have 3m minus 12 minus 2m plus 6. And now let's combine our like terms. So 3m minus 2m is just m, and negative 12 plus 6 is minus 6. So my denominator is this, and my numerator is that, okay? So I've got 4 over m minus 6, and that's it. We can't simplify that any further. So that's our final answer. All right, last example. Okay, so let's look at all of our denominators. So there's y plus 1. There's a 1 here. Remember, 1 over 1. And then there's a y minus 1. So our LCD is y plus 1, y minus 1. Okay, so that's what we're going to multiply the numerator and the denominator by. Okay, so I'm writing my numerator. And I'm multiplying times y plus 1, y minus 1, times y over y plus 1, okay? Now, what happens is this cancels this, and I'm left with y squared minus y. All right, so that's my total numerator here, is y squared minus y. All right, let's do the denominator now. Okay, so I'm also multiplying by the LCD. I just changed this right here to a 1 over 1. Doesn't make any difference though. Oh, I don't need that. I do need that. Okay, so whenever I multiply this whole thing times this, I just end up with that whole thing, okay? So I'm left with, oops, y plus 1 and y minus 1. That's a minus there. Okay, so that's what this times this was. Okay, now I've got a plus. I'm bringing down the plus. And whenever I multiply this whole thing times that, the y minus 1's cancel, and I'm only left with y plus 1. Okay, so now I'm going to distribute this out. And remember, since this is a conjugate pair, my middle term is going to go away, and I'm going to be left with y squared minus 1. I don't know where that came from. There we go. Plus y plus 1. Okay, and now I need to combine my like terms. So this cancels that, and I'm left with y squared plus y. All right? So check this out. So my denominator is this, and my numerator is that. So let's write that out. Y squared minus y over y squared plus y. Okay, now let's factor. Let's pull out the y's in the numerator, and we're going to pull out a y in the denominator. And these y's cancel. So I'm left with y minus 1 in the numerator and y plus 1 in the denominator. And that is it. We are done. All right, so that's it for this video. I know that this stuff is confusing. I get it. I totally understand. And it's really hard to be neat, but do your best to be as neat as possible with these problems, because it is very, very easy to lose things. So just go play in a tree, but use up some paper, okay? So I know, just stick with it, and you will be great at this. Practice makes perfect, and you really do have to practice at this in order to get good at it. Have a great day, everybody.